I'll give some better diagram. This may not help. And this the atom is there with the electron. We'll just show like this, small we'll say. And so now it will make a transition to n equal to 4. Now tell me what will happen to this particular atom. And in what direction the photon? The photon will be given out in this direction. This is a photon. This atom will recoil, and this I'll call the velocity of the atom. Can I, shall I ask you find the recoil speed of the atom? Let m be the mass of the atom. So when an electron makes a transition from fifth to fourth state, so what is the recoil speed of the atom? Why the atom should recoil? Because momentum should be conserved. Because the photon is having momentum, so the atom must recoil here. Opposite to direction of the photon open, it will have momentum. So initially it was at rest. Now it will eject a photon, the atom will recoil. So let's apply the conservation of linear momentum. Initial momentum equal to final momentum. Initial momentum 0, final momentum, momentum of photon, h by lambda, momentum of atom, mass of atom into velocity of atom. So what is velocity of this? Should be equal to h by m lambda. So what is lambda? We don't know. How to calculate lambda? So when it makes its transition from 5 to 4, how to predict lambda? 1 by lambda r is equal to 1 by 4 square minus 1 by 5 square. So r equal to 1 by 16 minus 1 by 25. Let me make it n equal to 1. Calculations will be easier. Let it jump to n equal to 1. So this will become 24 by 25. So what is lambda is equal to? 25 by 24r. That value I'll substitute here. H by mass of atom. Lambda is how much? 25 by 24r. Now you can ask some very good question here. What is that? 25 mr. This is the recoil speed of the atom. I'm assuming let it make a transition from n equal to 5 to 1. But you see that is it all the energy that is available due to transition of the atom from higher to lower state will be converted into energy of photon? No. If you actually write it, the difference is energy. What happen? A part is used converting to kinetic energy of atom, remaining energy of the photon. No. But if you look at the energy carried by atom, that will be negligible. That's why I'm able to write delta E is equal to photon. Practically what will happen? What are the decrease in energy of the atom? A part will be converted into photon energy, radiation, and the remaining will be kinetic energy of the atom. Because of kinetic energy, it should have momentum. But here, how I wrote this equation, the whole energy of the atom is getting converted into energy of photon. The reason for that, this will be negligible. Or else, no sir, if you say this is negligible, then recoil speed of the atom should also be negligible. As in fact, check it, what is h? 10 to the power of minus 34 Rydberg, and substitute all. So in fact, the speed of atom will be very small. So this will be, so they may test you, mains or advanced, they may ask you. Find this one. So or else you do one thing, take help of this. What is delta E? You should write here, SC by lambda and RSC equal to this much. Write it, RSC 24 by 25, write this here. Kinetic energy of atom, solve it, apply this conservation of momentum, bring it and solve it. No. Again, when you put that h square, f square will come. They'll become negligible, and finally this will be the answer.
Sir, R should be on the numerator, sir.
Which will be?
R.
R will be lambda. Lambda is equal to, here it should be, no, R by, lambda should be equal to 25 by 24R. 25 by 24R. Okay, no? Okay, there's a recoil speed of the atom is what we are proposing. I'm strictly saying, even you consider this equation and solve it, no, finally you'll end up with this equation because h square, f square will come. The square of h square will be definitely negligible. So finally, when you simplify, you'll end up this answer. It is a very popular problem here. MSET, I think some 4 times they've asked, not 1 to 4 times. From 5 to 1, 2 to 3, what is the recoil speed of the atom? No, this is a very important concept. Consider an excited hydrogen atom in state n moving with a velocity u. It emits a photon in the direction of its motion and changes its state to a lower state m. Apply momentum and energy conservation principle to calculate the frequency f of the emitted radiation. Compare this with frequency f naught